So line of best fit, we also call sometimes a regression line.
What's interesting? What?
I just did.
Say it in the way that
So a regression line, or a line of best fit, hopefully is a line representing data that appears to be linear. And oftentimes we call this data scatter plot, and we're looking for something like that. Line of best fit. Interpolation is making a prediction in between data points For example, if you had an x and y table, and I told you that 0 produced -4 and 5 produced 17, and then I ask you, hey, what about 3? And that's what you wanted to know. That would be called interpolation. Looking for an answer that falls somewhere in between the data that we're talking about. Whereas extrapolation is making a prediction outside of the data. So for example, if I have an x and y table and I ask the same kind of question, maybe I'd say, hey, 0 is -4 again, and 5 is 17 again. And then I say something like, what about 12? What is that going to give me? That would be considered extrapolation. Y hat, which looks like this, means the predicted y value, usually from our regression equation. So what ends up happening is, from our data, we will find an equation that fits it, and instead of writing down y equals something, which is the actual equation of a line, we will find a y equals, which is an equation of a line, but an equation that predicts what's going to happen based on our data. Y minus y1 equals m times x minus x1. Bless you. The x1, y1 is a point given, and m is the slope. So sometimes they'll give you some information like, here is a data point, and I know that this information changes at a rate of, and we talked about the word rate means slope, and then you'll plug things in. So the things that you'll be plugging in are this value and this value and this value. So those are plugins. You'll keep your y, there'll be a y, a letter y, there'll be a letter x, and they'll tell you about the slope at m, and they'll tell you about the point x1, y1. Let's look at an example. So in number 1, it talks about writing equations in point-slope form for each line. They tell us the slope is 2, and it's going to go through the point 4, -3. So I would write that as y minus -3 equals 2 times x minus 4. And you will see, if you're looking, that the negative 3 came from the y value in the point. The 2 was the slope that they gave me, and the 4 was the x value that they gave me. So I just plug it in. Now, of course, you should probably simplify this just maybe a little bit. Like, for example, maybe instead of writing down y minus minus 3, you should probably write it as y plus 3 equals 2 times x minus 4. And that's it. That's the equation in point slope form. So you just put the two minuses together. If you ever see minus minus, make it a plus. That's it. Let's talk about the next ones. So in the next one, using the same technique, I'm going to have y minus 5 equals negative 3 times x minus 2. Just make sure you're putting the x's with the x's, the y's with the y's, and the slope in front of the parentheses. If you guys have any questions at any point in time, just give me a holler. What's different about letter C? They talk about parallel, very good. They talk about parallel. So whenever you're talking about parallel, that means you want the same slope. So as I do this one with the parallel, what that means is I'm going to go with y minus the negative 2, because that's the y value, the negative 2, equals, and because they tell me I want a line that's parallel to the one that they give me, I want the exact same slope. So the slope that's with that parallel line is negative 1/2. And then I do my x minus 4. So as I'm looking for where these things are coming from, I see that first of all the negative 2 is coming from the y value. I see that my negative 1/2 came from the line's slope that they gave me, because parallel means I want the same slope. And I see that the 4 value came from the x value in the point. And so all of these things are coming from information that they have given me. And letter D is exactly the same as letter C, except you have to know perpendicular. It's the fans. You're not hearing things. It's okay. Calm down. Letter D works exactly the same. Oh, sorry, I should say that in letter C, of course, again, we would simplify this. So I would write down y plus 2 equals negative 1/2 times x minus 4, because you always want to simplify things. Don't forget to do that. Minus minus means plus. And then with perpendicular, works kind of the same as parallel. So I have y minus 6 equals, and then x minus the negative 2 on the inside of the parentheses. And this time, since I want something that's perpendicular to the line, instead of having negative 1/2, which I used in the last one, with perpendicular you want to flip the fraction and change the sign. So it was negative 1/2. So I'm going to write down positive 2/1. You flip it and change the sign. So again, looking at where these things came from, the 6 came from the y value. The 2/1 was the opposite reciprocal of negative 1/2. And the negative 2 came from the x value. And when you simplify, you would get y minus 6 equals, you don't have to write 2/1, of course, you just write down 2, and then on the inside it'd be x plus 2. That they give us here that is next to, give us some clues. And kind of the cool thing is, whenever there's zero slope or undefined slope, these equations are really easy. You just got to know what the pattern is. So in the first one, whenever they tell me about zero slope, what they're saying is that I'll have a 0 in front of the x. Or in other words, it's a horizontal line. So I know that whenever I have a zero slope, they're talking about a horizontal line. And horizontal lines are always in the form y equals something. And it's super simple once you see it. It's always whatever the y value is. So y equals just looks at the number 3 and puts it there. So whenever you see zero slope, it's always y equals a number, and it's always whatever the y number is from the point. Conversely, whenever they talk about the undefined slope, this thing will always be a vertical line, and always will be in the form of x equals something, and it's always the x value. So in this case, that means that x equals 9. So in this next example, this investigation thing, notice that we have a table, and I told you that in tables, generally,